So as an introduction to machine learning, I would like to clarify the difference between data science, artificial intelligence, and machine learning. So data science is the largest of all these fields and is the one that aims at extracting knowledge from data. So any data, any domain of the data, and using any means possible to extract information, knowledge from these data. Then artificial intelligence is actually a subset within data science. So it contains a set of algorithms that aim at mimicking human intelligence, human behavior. So in the extreme is what we see in the movies, right? So they are usually depicted as robots, some kind of humanoids, and the line between artificial intelligence and humans is blurred, so it's not easy to differentiate between the two. However, some of these human-like behavior can be hard-coded by the developer. Okay, so I, as the developer, I can say, look, if you encounter this situation, this is what you should do. This is how you go from A to B. So this is, which is the path that I want you to take, and this is how you do it, right? And that's where machine learning makes a distinction. Machine learning, again, is not a subset of artificial intelligence, and it contains algorithms or techniques that acquire this human intelligence like behavior autonomously from the data. So it's not hard-coded by the programmer, by the developer. It's learned from data, from experience. Now, machine learning models are interesting for many reasons, right? So as we have said, they are entirely data-driven, and they can build highly complex models, and they can handle large volumes of data. So what does this mean? Well, it means that I can tell the machine learning model, look, here is the data. This is your objective. So the data will be the input, the objective will be the output. Figure it out, right? So I don't need to have any prior knowledge of this input to output model or the path that is necessary to go from the input to the output, from the data to the objective. And no matter how complex that path is, the algorithm, theoretically speaking, will be able to identify or to find that path. And it doesn't matter how much data there are to process. Again, theoretically speaking, the algorithm will be able to handle, to analyze, to process all that data. Okay? And when I say large volumes of data, I mean in both dimensions. The number of samples that you can have and the number of variables or risk factors or independent variables, whatever you want to call them. Now, on the flip side, because some algorithms are complex and the input to output model can be very complex as well, they are not always easy to interpret, okay? And they are often referred to as black box. It doesn't mean that we don't know what's going on within that black box. We do know what's going on. It just means that it's not easy for us to express what is going on in a way that is easy for us humans to interpret, okay? Or there is no way, maybe. It just doesn't make sense for us because it's just a mathematical equation that is just not easy to interpret, okay? But we do know what's happening there. Now, they are opportunistic and they are based on correlation and not on relation. So what I mean by this is that they are blindly driven by their objective and by maximizing their success in achieving that objective. They don't care about the validity of the input to output models that they build. Okay? And that could be an issue, especially when we're talking about mental health research or health research in general. Okay? So that is an issue. They don't care about whether the details that they can find in the data and that they are exploiting to maximize that success, whether they make sense, and even if they do make sense or could make sense, whether those paths that they are finding, whether they are statistically significant. Okay? And finally, they are expensive. They require large volumes of data in many instances to be able to build these input to output models. They take a lot of time and computational power to train and to run, and that is not always available to us. Now, what is the typical structure of a machine learning model? Well, in a high level at least. So we have the raw data, and then we're going to manipulate this data to some extent. Okay? We're basically preparing the data so that it's easier for then the machine learning algorithm, the actual machine learning algorithm, to process. Now, the important message from this slide is that part of this data preparation will take place outside of the machine learning model, but part of it will be within the machine learning model. And this is an important thing to keep in mind and something that often people forget, okay? And we'll see more about this later and about why this is important.